in person.
Imagine that. Okay. Over here, over here. Share screen.
All right, and for this talk, Jeff Nader from Keck is going to talk to us about the current status of integration of data reduction and near real-time archiving.
Hi, everyone. Yeah, so I'm Jeff Nader. I lead the scientific software group at Keck, and I'm here on behalf of the DSI and COA teams, and that includes my colleagues just a short walk from here at IPAC. So yeah, I'm going to give you an update on how we are providing more usable data to you guys faster, getting it to you quicker as well. So this work is part of the Data Services Initiative project. So I'm going to start with a brief overview of that project, then talk to you a bit about how we're deploying DRPs. We recently had a pretty big change in how we archive data, so I will share that with you. And then I'll share how this all gets integrated into your observing model at Keck. Very important, how do you access all this data, especially data reduction pipeline data? And then I'll give you an update on the deployment status for this work. So the Data Services Initiative project, DSI, started just short of 2 years ago. The main goal of this project is to positively impact the science productivity of the observatory. And the way it's going to do this is by providing an end-to-end data infrastructure at Keck. And this will include tools that will help with preparation and execution of observations, and also the processes to reduce and archive your data. And so that's the part I'm going to focus on today. With these new tools in place, this will create data that is useful, usable, and quick. And so useful is better for the PI and also better for the archive users. Usable is well-calibrated data and well-understood data. And then quick is basically getting the data to you as fast as possible. There's 4 parts to the DSI project. Database-driven observing infrastructure are those tools that I mentioned for the preparation and execution of observations. The data reduction pipelines, we'll talk about. Changes to the Keck Observatory archive, and then the overall infrastructure changes at Keck that support the other 3. We do have a breakout session shortly that will cover the DDOI portion of DSI, but the rest of this talk will just be about those 2 in the middle there. So to provide more usable data to our observers and to the archive users, Keck is now providing fully supported DRPs to the community. These will be very robust, well-documented, and actively supported data reduction packages. And the requirements there, they shall be open source data, so they'll be available freely. All new instruments after KCWI. So with KCWI, we started using this DRP framework at Keck. And so all instruments forward have to use this framework. So KPF would be the next one there. Every DRP must provide a quick look mode, and this will be used while you're observing to provide you feedback on that data. And then Keck will deploy 4 of these by the end of this coming February. The scientific software group will be involved in this development with the DRP teams, and we already are engaged with several of them. All of these DRPs will be written in Python and available freely on GitHub. And I mentioned the instruments after KCWI. So the ones before KCWI that were already being used for science at Keck. We have partnered with the Pipet team. That is a team led by Jason Prochaska and Joe Nalway and others. That a little bit more about Pipet. It's a Python package, and it does spectroscopic reductions, not just of Keck Observatory, number of observatories, but we'll focus on Keck here. The current status of Pipet, it was good to hear it called out in the first talk this morning, but it is fully supported for the DMOS and MOSFire instruments. Other instruments are currently in development. You can see NIRES will be coming soon in the next few months. LRIS is being developed. It includes the slit astrometry, and then a KCWI mode, and the near spectrum low dispersion as well. Also under development for Pipet is this DMOS Quick Look GUI. This will be available while you're observing, so that will interface with the data reduction package as well. And then high-res and ESI are coming a bit later. There is a Pipet workshop in October, as you see there. If you are interested in that, just join their Slack and you could figure out or find more about that. For COA, so before DSI, your data was being archived the day after it was taken. So you would observe all night long, and in the morning, the process would come along, collect all the data from the previous 24 hours, and then send it to a building down the street here and archive it. In order to provide data quicker, of course, that's a model that we have to change. And so COA did pivot, and we now have to archive the data as soon as it's written by the instrument software. So this mode we call RTI, or real-time ingestion. And it will include the ingestion of quick look data as well from the DRPs. And the requirements on this mode of COA are that the raw data must be archived within 5 minutes. And our internal team goal is 1 minute. The quick look data must also be archived within 5 minutes, and the fully reduced data archived within 24 hours. So I'll give you an update later on our status of those numbers. So this ugly plot here, but what this shows is basically you taking exposures on the left there in green, repeating that all night long. And the dashed line is what the current or old way of archiving data was. It just waits until the morning, and at some point later in the morning, it archives all that data, and then it's available to you through COA. But I'm glad to report that disappears, and this is our new model. This is RTI, and so after every exposure readout, RTI is now automatically detecting that. It produces this raw data product, ships it over here to California, and archives that data. So that process is happening all night long now, but it doesn't end there. That raw data product, once it's created, the DRP kicks in. It produces a quick look data product, which is also shipped to the archive and archived. This process is fully automated and it runs all night long, but there's one more piece at the end of the night. So let's say you take some standard stars in the morning, or you take additional calibrations, the DRP automatically kicks in one more time in the morning and produces a fully reduced data set for the night and ships that to California to archive. So in summary here, your raw data is available within a few seconds in the archive, available to the PI and anybody that has access to that data. The quick look data is available within a couple of minutes, and the fully reduced data usually within about 4 hours or so of the end of the night, depending on the DRP. I like this graph or this plot here. This shows a KCWI night back in May, and it shows the flow of these processes throughout the night. And so what you see here on the top are your science exposures with KCWI, followed by that thin red line as the readout time, followed by an even thinner green line. That is the time to archive the raw data product. And then the DRP immediately kicks in after that. And so the orange is the processing time for the DRP. And then once again, a archiving of the quick look data set. And that repeats all night long now. The zoomed in region there is actually that shaded region, but that's just showing how quick this is happening and that you are able to access that quick look data product, well within, say, your second exposure is completed. So it allows you to make real-time decisions during the night on if you need to change your observing structure or not. Important question, how do you get all this data? So the current user interface for COA can be used. You can download, you can search for all of this data through that interface. But I'm excited to let you know about a new interface we're developing. It's called the real-time user interface. It's a web-based system that you use while you're observing. And it will have a table that automatically updates as data is being archived. It will have viewing of the data in the browser. And the part that I really like is it will automatically stream this data directly to your laptop or your computer that you're running the browser. And multiple users, as long as you have access to this data, multiple users can have this up and running. So I'm going to show you a demo of our current prototype here. If it starts, yeah, there it goes. So this is me observing on Keck 1, and I want to download files. So I just toggle that button there and wait for files to come in. And I'm using Osiris, so there's my first image. Now watch the upper right there. There's my download. I now have that on my Mac. There's a second one. There's a second download. So this can be used all night long. If you like the rsync data, use this instead. No longer need to rsync your data. Just to show you some timing, I mentioned the 5-minute requirement to get raw data to the archive. We're well within that. We're well within the 1-minute goal that we set internally. And we're actually well within 30 seconds. So that tall green there is high res, and we get that about 8 seconds from instrument right up. And on Keck 2, it's very similar. The peak out at 30 seconds is DMOS files. Those are our largest data files, so they take a bit longer to transfer to California. And the quick look data for KCWI is a little over 2 minutes, maybe 2.5 minutes that it's getting to the archive. So John showed you this morning in his talk. Stole a little bit about my thunder, but that's okay. He's my boss. He could do that. But this table is showing the current DRP status of deployments on the left and the RTI, that's a real-time ingestion update on the left or on the right, sorry. And yeah, the raw data for all 10 science instruments at Keck are now being archived as part of real-time ingestion. So as you're observing, they are getting archived and they're available to you that night or during the night. KPF and KCRM will come next. As for DRPs, we have KCWI was our first DRP that was fully deployed at Keck. It includes quick look data and science ready data. Our first pipette instrument was DMOS, and that has science ready data. The quick look GUI is still coming. Happy to report that MOSFire, the second pipette instrument, is just about ready for deployment. It has been installed at Keck. It's been tested. It's been verified. It's been integrated with RTI. And so we just need to schedule a release for that. But we needed 4 by February, right? So that's 3 of them. The 4th one will be KPF when it comes online in 23. So we will meet that requirement as well. Just a summary, your raw data is being archived all night long now and available to you through COA. As we deploy more and more DRPs, we'll get more and more quick look data and science ready data to you very quickly during the night and soon in the next morning. And then soon we will have this new web-based UI. And I hope you're excited about this. I am, but getting that data to you automatically through your browser is a pretty cool tool. So thank you very much, and I'll take any questions.
Well, we lots of opportunities to breakout sessions, but any quick questions we can take now? This is Ben.
So this pipeline system seems very well optimized for CCD data and live data, but there's a couple future-proofing things that seem missing. So, for instance, Maxwell Atlantic is working on a speckled interferometer. It's going to be it'll be taking data at multiple kilohertz with 2K by 2K image sizes. That's going to give you much more than 10 terabytes of data. And then I might be interested in telemetry data from Keck, which for my analysis, which is not being recorded or archived. So, and also the MT vectors we've done at Subaru, we basically broken Subaru's brain. They have no idea how to handle us. We don't have an integration time. We don't fit into any of these paradigms. And a lot of this is even something like STMOC might not fit into this in the future either. So I think thinking about higher, future proofing, especially the rules, because the rules can get in the way of innovation.
Yeah, definitely as the data get larger, we don't reduce data, we actually increase the data as we reduce the data. But yeah, the transferring of that data and the telemetry data is a lot of data to deal with. So.
Okay, good. There.
So you mentioned that all of the future pipeline will be based on the Keck ERP framework. Can you explain more about this framework and how it's beneficial?
I'll give you a brief definition of it, I guess, and we could talk more about it at the breakout session. I do have one of my DRP team members here, but the framework is, I guess the way I'd say it is, it's a way to create recipes for your reduction processes, and it kind of manages the processing of those recipes and make sure they finish, and then starts the next step and then follows through that process. So that's what the framework is doing.
Okay, Adam.
This is really very exciting to provide this progress. I wanted to know a little bit more about kind of the constraints of the automated reduction. So for example, is it only point sources? Are there certain conditions in which reduced data will not be possible? You mentioned like right now packages will be low risk, but packages in 2025 are high risk. Do we have an idea of kind of the constraints of the reduction compared to what we have to do?
Yeah. Yeah, it's a fully automated process. So the DRPs are started every day automatically. There are going to be use cases where the DRP doesn't work. I don't know what a good percentage is that might happen, but maybe 5 or 10% or so.
Omera is 85% clear.
Okay. But yeah, it's not, it won't work for every science case, but I think it will hit, well, like John said, 85% of them.
All right.
I just wanted to ask a little more about the status of Osiris and moving it out of IDL. Is that being done painstakingly and manually, or is there some clever automated way to turn IDL into Python? And how many person months is it taking? And I might be asking someone who owns a different instrument than Osiris.
Yeah, right.
Data pipeline.
Right now, we are sort of piggybacking on the IDL pipeline to get you that
Yeah, I
data.
can see what you're doing. I'm thinking like the 2024 box on your left.
Yeah, it's going to be a big effort to make that DSI compatible. I don't think there's any plans for it yet, but that's why it's so far out there. But yeah, the hope is to get that over to Python as well, into this system.
There might be some interesting, the Gemini Planet imager Python pipeline, has the same heritage, so there might be some way to share effort.
And so Cyrus Working Group is also looking at various options.
Oh, good.
For this. Okay. So is that fair?
How many people can use the real-time interface at once?
That would be my canned question for my team member. Well, hopefully anybody could use it, at the same time, but we do definitely still have to do a lot of testing as far as the downloads and different data sizes and stuff. But as you're sitting on your couch in pajama mode, different team members, all of you should be able to have this UI up and running and downloading data. Is that good, Max?
So I'm going to put on a hat that I put on in 1998 for the first time as somebody who had to go home with tapes. And because I forgot to do this during your demo, I just got to say, dude, right? I mean, I know I'm your boss and I'm biased, but I do want to give a shout out to Jeff and his team and the next team. This streaming thing is just the tip of the iceberg of some of the stuff that we want to bring in terms of data accessibility and data visualization. I think Adam, if the answer to your question is, that's why we're open sourcing it. Because we want to be able to incorporate as many use cases as possible, or at least get you far enough. And my minimum requirement with the QuickBooks data is the ability to gauge the scientific viability. Not always get you straight to the science answer, but at least tell you how, are you on the right track? Should you abort the next exposure because you got what's needed? So anytime the community has an idea on how to incorporate that into the pipeline, say extended objects or multiple objects and split, et cetera, just reach out to me and I'll put you in touch with the right people. I do want to get the community space as possible, and get people the answers that we need.
And I think that we try to make updates the archive. And so it's very hard to push through the screen, so that's, I appreciate it.
All right, so we will have a lot more discussion in the breakout session, so